Welcome, ladies and gentlemen. May I have your attention, please? Thank you and happy Monday to everyone. So I'm super excited about today for a variety of reasons. One, we're going to generate our derivative shortcut rules for our other trig functions. And so we already have derivative shortcut rules for two of our trig functions. We're going to go ahead and figure out how to apply derivative shortcut rules to our remaining four trig functions. We're also going to get your test back so you can see exactly how you gain or lost partial credit. And we'll continue developing our rules sheet. And so we've already got product and quotient added there on the back whiteboard. Today we'll be able to add four more shortcut rules to our derivative sheet, and we're getting pretty close to being done. And so that means that we need to be committing all of our shortcut rules to memory, and we'll be having a quiz after 2 class periods in which you'll simply state the derivative shortcut rules in words. And so just like we wrote down in our last activity, the derivative of a product of two functions is the derivative of the first function times the second function plus the first function times the derivative of the second function. You're going to write that out in words and get full credit for the product rule derivative. The derivative of a quotient of two functions is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. You get full credit on the derivative of a quotient. And so while we spend a lot of our time doing problems, applying those rules on our last test, your derivative rules quiz is going to be stating the rules in words. It's very important that you memorize these because our functions will get more and more complicated. All right, more about that later. In the meantime, let's go ahead and take a look at your Bellwork. So raise your hand if you did not get a red mark for today, the 26th. Let's go ahead and apply some of those shortcut rules right now. And so overall is my number one function. Overall, is that a trig function or an exponential function or a power function? So overall, what type of function is number one? Right. Jake?
It's an exponential.
It's an exponential, good. And so it's not just the derivative of 3 to the x, though. It's the derivative of 3 to the cosine of x. So I'll be using my chain rule. The derivative of an exponential function overall is the exponential itself. That is 3 to the cosine x, right, times the natural log of the base. In this case, the base was not just e, it was 3, so we need that. And now times the derivative of the inner function. My derivative of the inner function would be the derivative of cosine of x, and that is opposite sine of x. And so if I went ahead and rewrote this, we would get negative ln 3 sine of x times 3 to the cosine of x. And really any order is okay there, so long as we put the negative out front so we don't think it's subtraction. Raise your hand if you got the equivalent for number one. Woohoo! Good job. So make sure you remember the natural log of the base as you apply the exponential rule. All right, number two. Now we've got a quotient of two functions. And so when you see x appearing more than one time in your function, we know that's a candidate for the product rule or for the quotient rule. In this case, we saw that if we have a fraction with x's both in top and bottom in two separate functions, it was much easier to apply the quotient rule than it was the product rule. So let's go ahead and apply my quotient rule to f of x in number two. The derivative of a quotient of two functions is the derivative of the numerator, sine goes to cosine, times the denominator, e to the 2x, minus the numerator, that is sine of x, times the derivative of the denominator. And remember, my denominator here is exponential, so it's an exponential rule. That's e to the 2x times the natural log of the base would be ln of e is just 1. But I have an overall function and an inner function. So I still need to multiply by the derivative of the inner function. My exponent wasn't just x, it was 2x. So I still need to multiply by 2. Does everybody see that? The derivative of e to the 2x is 2e to the 2x all over my denominator squared. So all over our denominator squared, and the original denominator was e to the 2x. So that is squared. All right, let's take a look at the first step to make sure we have it. The derivative of a quotient of two functions is the derivative of the numerator times the denominator function minus the numerator times the derivative of the denominator function all over the original denominator squared. Awesome. And that looks a little messy, so we can make that look a little bit better, I think. Go gadget arm. What if we took out an e to the 2x from each of them, so I can get e to the 2x. And then I would have cosine of x minus 2 sine of x. Close numerator all over denominator e to the 2x squared. And why was that helpful? Well, now we notice a common factor of e to the 2x appearing both on top and on bottom. We could divide out that common factor and equal 1. So my final fully reduced answer would be cosine of x minus 2 sine of x all over e to the 2x. Go ahead and take a look at yours. Raise your hand if you got that. Did anybody get all the way to the end? Yes, you did. Way to go. Good job, you guys. What question do you have on number 2? You have to memorize your derivative shortcut rules. Memorize your product and quotient in words, and that'll be a leg up for your derivatives rule quiz coming up. Okay, so memorize those in words, and that'll help. All right, now we could go ahead and choose. I have x appearing in 2 separate functions. So I know this is a candidate for the product rule or the quotient rule. However, as I look at this, right, we saw that product rule, well, we can do it both ways. We can do it both ways, but I also see that negative exponent is screaming at me reciprocal, and that would give me a quotient rule if I rewrote that as x cubed over e to the positive x, and we saw the quotient rule was easier to apply. So the choice is yours, right? I think we'll go ahead and do it. Well, raise your hand if you did a product rule. So who did a product rule? So let's do product rule first, and then let's compare it with the quotient rule. So no problem. The derivative of a product of 2 functions is the derivative of the first times the second. There you go. Watch that, man. Plus the first times the derivative of the second. Ooh, the derivative of e to the negative x is the exponential itself, right? Times the natural log of the base, times the derivative of the inner function. In this case, the exponent is negative x, not just positive x. And so what do we need to do? Well, the derivative then will be negative e to the negative x. When I do the derivative of the inner function, that'll spit out a negative, right? The derivative of negative x is negative 1. Awesome. So what does that equal? That equals 3x squared e to the negative x minus x cubed e to the negative x. We could leave it like that. We could recognize that that e to the negative x is really 1 over, right? 1 over e to the positive x. I want to compare it though with quotient rule and see which we like better. So alternatively, we could have rewritten our original as p of x equals x cubed over e to the positive x. And I'm wanting to do that just so that I can compare it, the product rule application with the application of the quotient rule. So there you go. The derivative of a quotient of 2 functions is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. Was that helpful at all? Well, it is if we again take out the e to the x and get 3x squared minus x cubed all over e to the x quantity squared, because we can then divide out and factor e to the x and get 3x squared minus x cubed all over, oops, e to the x. How in the world is that equivalent to my original product rule? This e to the negative x would be 3x squared over e to the positive x. This e to the negative x would be minus x cubed over e to the positive x, and write that as a single fraction that has 3x squared minus x cubed all over e to the x. So either one is fine. I guess I just don't like the negative exponents there. Ew. The heebie-jeebies. Of course it'd not be giving you the heebie-jeebies. All right, what question do you guys have on number 3? Number 4, ooh, is number 4 a candidate for the product rule? Right, is number 4 a product rule? No, x is not appearing in two separate functions where we've got a product or a quotient. Instead, this is a chain rule, and so it's helpful to think about this as overall function versus inner function. And I'm thinking that a quick rewrite to show this is right. This is overall a power function. It's a power function. This is sine of cosine of x all squared. So I'm going to apply my power rule as the overall derivative, and then I'll have an opportunity to do trig rule with a chain. And so this is 1, 2, 3 links, right? This is 3 links in my function. That's pretty sweet. Let's do it. So t prime would be given by overall exponent times the base raised to 1 less, and now times the derivative of the inner function. Sine differentiates to cosine with the, right, okay? Sine differentiates to cosine with the inner function. Almost there, almost there. And then times the derivative of the inner function. And so we still need to do times the derivative of that angle. The angle was cosine of x, and the derivative of cosine of x is opposite sine of x. And so I think we got all the pieces. Let's check. Ready? So overall, we did a power rule. That's exponent times the base to the 1 less than the exponent. So that's 2 sine of cosine x to the first. Then times the derivative of the inner function. That's sine of cosine of x. So let's do the chain rule. The derivative of a sine function overall is a cosine function with the angle. And now times the derivative of that innermost function, that's negative sine of x. So we'll put it all together and let's make it look a little prettier. It looks like we'll get negative 2 sine x Okay, so we've got negative 2 sine of x, sine of cosine of x, cosine of cosine of x. Wow. And if we thought algebra, right, if we thought algebra was bad, calculus is a little bit alphabet soupy, isn't he? Isn't it? Look at that. Awesome. What question do you guys have about 4? And 1 to go. We can now, surprise, we can now handle this a couple different ways. So before we rewrote this as a power. We rewrote that as quantity 4 minus x to the negative 1, and we applied our power rule. However, now we can do it with a quotient rule because this is a quotient, right? A quotient because I have an x function in the denominator of fraction. So let's try it with the quotient rule and compare. I'm not even know who did it with the product. Who did it with the power rewrite? Did anybody do 4 minus x to the negative 1? Nobody did it that way? Yeah? Okay, so let's compare it when we do the quotient rule. Ready? The derivative of a quotient, right? A quotient is the derivative of the numerator. The derivative of pi cubed is not 3 pi squared, it's just 0, right? Times the denominator. Minus the numerator, that's pi cubed, times the derivative of the denominator. What's the derivative of 4 minus x? Negative 1. There's the derivative of my denominator function. All over the denominator squared. And so that's quantity 4 minus x squared. And now we see this 0, right, times the quantity. That drops out, negative times the negative. So I'm getting pi cubed over over 4 minus x quantity squared. There we go. So where's the negative? Yeah. So normally we get a negative 1 over x squared, right? But now because my quantity 4 minus x had a derivative that was negative 1, it cancels out. So we get positive. Awesome. Great. Savannah, how did that compare?
Mine was different.
I got you. With the product Or with power rule? Okay. What questions do you guys have on number 5? All right. Then let's take care of our OTL number 2. So OTL number 2, give yourself credit for those that you completed out of 20, please. Divide, enter, multiply by 2. If you have multiple pages, please staple them together, and there's a stapler on the side activity table. And one on the front table. After our OTL collection, we'll go ahead and get your test back so you can see exactly how you did. But first, you need to take care of your homework. So please make sure that your proper heading, name, first and last, 2A, number 2 are clearly labeled. Infinite gamma score box nice and big. And then go ahead and pass from the back to the front, please. Thank you. We'll go ahead and pause the recording now. Okay, ladies and gentlemen, so what's going on today? Today, we're going to generate our shortcut rules for the other trig functions. And so I want you to think, which trig functions do we already have shortcut rules for, right? Which ones do we already have shortcut rules for on our rule sheet? And so what derivative rules for trig do we already know? Emily? Sine and cosine. So we already know that the derivative of sine of x, right? The derivative of sine of x is cosine of x. We know that the derivative of cosine x is opposite of sine of x. And so, which trig functions do we still need, right? Which trig functions do we still need? Evie?
We need tangent of x, cotangent of x, secant of x, and cosecant of x.
Nice. And so our goal today is to develop rules for tangent of x, the derivative of cotangent of x, the derivative of secant x, and the derivative of cosecant of x. Absolutely. Thank you. So I'm excited about that. Oh my gosh, because we're going to be so close. We'll only have one more day of derivative shortcut rules, and then we'll have all of our rules. So we'll be able to calculate derivatives for any kind of function. Today you can understand that the matching, so after you match the original function with their potential derivatives, I need to check that, so you get a stamp before we do any sort of proof. Then you're going to be assigned, based on what group you're sitting in, your group is going to be assigned one of the 4 to prove. Then you're going to come up and write your response on the whiteboard, right? We'll round robin it so that different people in different groups will have a chance for sharing their proof. And then after we get the correct derivative rules, we'll add those to our rule sheet, and you'll have a chance to earn your practice stamp. Many of you will earn your practice stamp while you're still in class today, okay? And then we'll come back together for closure. And so once again, we've got 1 stamp at matching. After you get your matching stamp, I'm going to assign your group one of the 4 to prove. Then we're going to go ahead and get a stamp at the end of your proof, and I'll send you up, right, based on which group you're in, I'll send you up to share your proof on the board. And then after everybody's done with their proofs, then you get a chance for your practice step, and you can continue doing that in your group. Okay, questions about what the next segment of class is going to look like? Great, so the first one will be after your matching. Go ahead and scoot into your groups. If you need to move because it has some people, that's fine. I want to make sure that everybody's in a group of at least 3 to 4. So you can move to join groups based on absent people. Firstly, a big thank you to those of you who came up and shared your derivative proofs. And so everybody, let's take a look. We now have generated derivative shortcuts for tangent of x. By using our quotient identity, we can rewrite, right, tangent of x is sine of x over cosine x, and then apply the quotient rule. Thank you for showing work. Look at the Pythagorean identity. So good, right? So right. The Pythagorean identity allows us to combine, right, to rewrite cosine squared x plus sine squared x is 1, and then we can do our reciprocal identity to close it out. So we've got our derivative of tangent. Our derivative of cotangent. Nice job with the quotient rule, again. This time we have a negative spit out. Secant differentiates to secant tangent. Thank you for showing your work. I appreciate that. Nice job with the split up for the fractions. You see that was a key step there. And then lastly, cosecant differentiates to opposite of cosecant, cotangent of x. And again, the split up is what allowed us to facilitate that. Okay, so ladies and gentlemen, this is what we need to do now. On your rule sheet, everybody at this time, please add to your rule sheet the derivative with respect to x of tangent of x. And so the derivative with respect to x of tangent of x on a rule sheet And what are we going to put for that then? What's our derivative of tangent of x then, Preston? Absolutely, thank you. So the derivative with respect to x of tangent of x is secant squared of x. Good. On our rule sheet, we'll add the derivative with respect to x of cotangent of x. And so what's the derivative with respect to x of cotangent of x? Allie?
Negative cosecant.
Good. Negative cosecant squared of x. On our rule sheet, we'll add the derivative with respect to x of secant of x. And so what did you get for that? The derivative with respect to x of secant of x. Jake?
Yeah, secant of x times tangent of x.
Good. Secant of x times tangent of x. And lastly, the derivative with respect to x of cosecant of x, right? The derivative with respect to x of cosecant of x. And if you need to look on your matching too, what do we have for that? Nikki?
Negative.
Awesome, thank you. So take a minute to make sure you have your rule sheet updated. We'll now work to apply those to our 4-4 practice. So we've got a combination, we've got product rules, we've got quotient rules, we've now got our trig functions here. You're welcome to use your smartphones or electronic devices to be checking your answers, and when you agree with the key, then you can go ahead and call me over and I'll get you your final stamp for the day. That is at the end of 4-4 practice. After you've checked your answers, that's a practice stamp for a total of 3 possible today. Next class, we'll add our words to our rule sheet, right? And we'll come together for our closure, so I'll go ahead and do a final pause on the recording. And after our practice stamps, we'll do our closure. I appreciate your help returning the desk. I just want to point out for everybody, I put it on the agenda, but I want to make sure that you know this week's little discussion forum is a fun one. It's called Antiderivative, or Are You My Mommy? You're going to be charged with the task of coming up with an original function, right? Just an equation, y equals, differentiating it, and generating y prime. Then you're going to post your y prime, your derivative equation, on the forum. After reading other people's responses or posts, you're going to choose a classmate to reply to and figure out their original function y from whence it came. And so it's antiderivative. You're going backwards. And that's the practice with our rules, because you're going to, of course, having your rules quiz coming right up. Some of you have already posted, so thanks. But I want to make sure that we have our new rules. So here we go. Be ready to share it. Ready to go to your closure note sheet. If y equals secant of theta, then y prime equals. Go ahead and tell the class, get ready. What does secant theta differentiate to? Meg?
Secant theta, tangent theta.
Good, thank you. Good job with the angle. Secant theta, tangent theta. If y is given by cotangent of w, right, then y prime is. Get ready. Allie?
Negative cosecant.
Cosecant?
Of w.
Yep.
Squared w.
Awesome. Thank you. Perfect. If y is given by tangent of p, then y prime is. Kobe.
Secant squared p.
Good job. If y is given by cosecant of x, then y prime is. Savannah.
Negative cosecant x times cotangent.
Awesome. And here's the good stuff. If y is sine squared of m, we can now calculate y prime. If y is cosine of t squared, then we can calculate y prime. Okay, so some chain rules at the end of the day. Meg, let's go to number 5.
2 sine m times cosine m.
Nice job handling the chain rule. The derivative of the overall function is power, right? Times the derivative of the inner. Nice job. And cosine of t squared. Sophia?
Negative 2t sine t squared.
Nice job with the chain. There's my derived in the inner. Great work today, ladies and gentlemen. You can still get your 7 stamp. If you bring it to Bellwork next time, you still get full credit on that. Great job. Let me know if you have questions or concerns.